So for question number 8 off of the target round, reads points D, E, and F are midpoints of the sides of ABC as shown below. Let G be the point at which line AD, line BE, and line CF intersect. Given that AG equals 4, BG equals 6, and CG equals 8, what is the square of the area of ABC? Well, first of all, remember that a line from one vertex of a triangle to the midpoint of the opposite side of that triangle is called a median, and the medians intersect at the centroid. So G is this triangle's centroid. And ABC has medians AD, BE, and CF. Remember that the centroid of a triangle divides those medians into segments with a 2-to-1 length ratio, and the longer segment is closer to the vertex. So in this case, if line BG is length 6, then GE is going to be half of that, or 3. If line AG is 4, then GD must be 2. And since CG equals 8, GF must be equal to 4 to satisfy our ratios. Additionally, notice that, and I'm going to specifically focus on triangle AGC here, but this will also follow for triangles BGC and BAG, that triangle AGC is a triangle with the same base as triangle ABC and a third of the height. So triangle AGC is going to be 1/3 the area of triangle ABC. And since in triangle AGC, triangle EGC has the same height but half the base, triangle EGC is going to have half the area of triangle AGC, and therefore 1/6 of the area of ABC. So all we need to do is find the area of EGC, and then from there, we will be able to multiply that by 6 and find the area of ABC. Now, since we know that triangle EGC is 1/6 of the area of triangle ABC, let's go ahead and say that length CE is equal to S. And then line EA will also be equal to length S. And then by applying the law of cosines to triangle EGC and EAG, we find that GC, which is 8 squared, equals EG, which is 3 squared, plus EC, which is S squared, minus 6 times S times the cosine of angle GEC, and that 4 squared, which is AG, equals EG, which is 3 squared, plus EA, which is S squared, minus 6S times, I forgot to write it in cosine, my apologies, times the sine of angle GEA, or not sine, the cosine. My apologies. Now, since GEC and GEA are supplementary angles, aka they add up to 180 degrees, the sum of the cosines of GEC and GEA is going to be equal to 0. So when we add these two together, we get that these two terms cancel out, and we're left with 80 equaling 18 plus 2s squared. And then solving for s, we get that s squared equals 31, or the square root of s, or s is the square root of 31. You can write that either way. Now, if we were to drop an altitude of length h from E to CG, and we were to call the smaller side x and the larger 8 minus x, then by the Pythagorean theorem, we're going to have that x squared plus h squared equals 31, and that 8x, or not 8x, 8 minus x squared plus h squared equals 9, where h is the height of the triangle with EGC with base CG. And then subtracting these two equations, once we have simplified them a bit, gets us 16x minus 64 equals 22, or that x equals 43 over 8. And then plugging this back in, we get that 441 over 64 plus h squared equals 9, which we can write as 576 over 64. And then from there, h squared equals 135 over 64. So the area of triangle EGC is going to be 1/2 times 8 times h, where h is the square root of 135 over 64. Multiplying all this out and simplifying gets us 3 root 15 over 2. So the area of triangle ABC, which is 6 times that, is going to be this times 6, or 9 times root 15. And then the square of that is going to be 81 times 15, or 1,215, which is our answer.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.